Well, it looks like we have a pretty good group now. Do you want to get started, Brian, or do you want to wait another minute or two?
Yeah, I might as well get going. Turn the camera here for a sec. Hey guys. Yeah, so thanks everyone for joining. I'm excited to present my ecosystem, what I've been building at Aviary Tech. I'm hoping that maybe looking through the code and stuff might help participants kind of figure out how DIDs and VCs work, and there's a couple other things that I'll show you and give you links to and stuff. I'll also just kind of go through some of the newer innovative things that my company's been working on. So yeah, let's dig in here. Great. Cool. Yeah. So like I mentioned, I'm the founder of Aviary Tech. Right now, it's just a small company of myself and my brother helping on the design/art side. Hopefully going to be hiring soon once I, get a little bit of, once my projects kind of kick off the ground in the next little bit here. Yeah, so my main goal, mission of Aviary Tech is kind of to build basically more privacy preserving technology for the internet. It's just broken how it is right now, as we all know, and I'm hoping to help push things in the right direction. So, yeah, like I mentioned, the design principles are privacy by design. So everything, basically making it so that me as the software provider, I basically can't do anything evil. Google's old phrase, "Don't be evil," that they got rid of. They removed that tagline, but I want to make my tagline, "Can't be evil." And then another design principle is to leverage zero trust architecture. So basically build trust on top of starting from nothing. So using DIDs and VCs, you can do that by like Charles mentioned before, and a couple other sessions. Basically, claims about an identity can be made in a verifiable manner, and that leads to cryptographic assurances as well, which is how that fundamentally works. You can also do other things that we haven't really touched on this so far, like such as encryption, which is a really big important thing. So over the past few years, basically, I've been building a few different libraries and tools. They're all built in TypeScript, and they work on both the browser and the backend in Node. So I have some crypto suites that I've worked on. I'll dig into which ones in a bit. There's more coming, and there's just want to make sure I have tooling for kind of all of the big ones that that everyone seems to use, which will make sure that my tooling is interoperable with the broader ecosystem. I also have some open source code for verifiable credentials, which handles the issuance of VCs, basically signing VCs and doing all that stuff. It also handles presentation of verifiable credentials. So when you are a holder of a credential, you want to be able to show it to people and basically present those claims about yourself. And then finally, also, of course, the verification side. So requesting credentials and claims from somebody and being able to verify that the credential is valid. And then also, I've been building tools for DIDs. So there's a couple of DID methods that I've been focusing on. I'll go into those in a bit here. But basically, I've been building tools to allow you to create them, update them, resolve, and deactivate DIDs. And then the last library that I've put a lot of time and effort into is my DIDCOM messaging library. So DIDCOM is basically an approach for DID to DID communication. So it allows you to send a message from one DID to another DID over an encrypted, basically encrypt that message for the other participant, send it over to them, and then they can use their private keys to decrypt it. And then finally, I'm also been working on a custom DID method I just released recently. It's called DID BTCO, and it uses the Bitcoin blockchain. It is quite new and rapidly developing, but it's a pretty exciting one. It uses a new technique on Bitcoin called ordinals. So it allows you to basically inscribe your DID document and do some fancy things to update it and deactivate it. And since it's on Bitcoin, anyone can read it as long as they have access to a ordinals node. So on the verifiable data side, the VCs, basically I have built all my tooling to be W3C VC DID model compliant. I'm keeping an eye on the work being done in the VC working group as well, and we'll be folding in the 2.0 version as soon as it's ready for production, basically. And I personally have been focusing on the JSON LD variant of verifiable credentials. There's a couple other, there's a VC JWT, which is getting a lot of adoption. However, all of my tooling has been built so far around JSON LD. But I do have plans to integrate the other formats as well, but it's just on my future roadmap. Yeah, as I mentioned before, I have issuer, verifier, and holder services, and a lot of my tooling focuses on the W3C CCG's VC API work, which is a protocol for issuing, verifying, and presenting. And but I do have plans on working on the OIDC flows, which is a different approach for that. And then I also have, as I mentioned before, a lot of DIDCOM tooling. So on the DIDs front, basically I've made sure that all my tooling is V1 compliant. And like I mentioned before, I have a newer method that I'm working on and hoping to basically get that into production as soon as possible with it, which is the ordinals method I mentioned. And then some of the main methods that I've built on so far is the DID key, as Charles mentioned in the previous session, which is a static key that you can embed inside the identifier, which means there's no network request or anything. And then another one you mentioned, DID web, which is being able to basically put your DID document on a web server and allow people to resolve it. And then the last one there, DID peer, is an interesting one. It allows you to do a little bit more than DID key by embedding service endpoints in your identifier, as well as other types of keys. So it's not a single key. You can include encryption keys as well as verification keys, and as well as service endpoints, as I mentioned. So with DID peer, you can basically bootstrap a DIDCOM connection without any ledger at all. The trade-off for that is that the DID peer identifiers are quite long because all of the information is embedded in them. So as far as the crypto suites that I've built so far, basically I've built the BBS BLS Signature 2020, which is the one that allows for selective disclosure. Tomislav mentioned that one in the Trinsic session earlier this morning. I've also built JSON Web Signature, which is an interesting one because it allows you to do quite a few different key types within a single kind of crypto suite. It uses Jose and its family of cryptography. A couple other of the kind of the main ones that you see around are 825519 signature 2018, as well as 2820, which I don't have listed here, and then X25519 key agreement for encryption. So as far as DIDCOM, basically I've implemented some of these protocols that you see here. This is just a short subset of the ones that I use quite often. The basic message just allows you basically to send a encrypted basic message from DID to DID. The out of band, allows you to create basically an invitation that you can use to start the connection with another participant. And then the present proof is one way to present verifiable presentations. which include all of the VCs inside of it. And then the issue credential is the flip side of that. It's the issuing credential from a issuer to a holder. So my suite of applications and tooling is called Aviary AV1. And basically what I've done is split all three of the roles that you commonly see in this world, issuer, verifier, and holder, into three different parts. So I have tooling and applications and stuff that I'm building that are going to focus on verification, as well as issuance, and then as well as a wallet holder situation. So basically my first product that is going to be coming out later this fall, and it's currently in alpha with a few testers playing with it, is called OneKeep, and it's the wallet side of things. And basically it is it's a web application with a browser extension that kind of complements it and holds all of the private keys. I do have plans on eventually getting it into a mobile form factor as well, but it's just on the future roadmap. So for now, it's a web interface with it has the chat built in, like I mentioned, and kind of a suite of different kind of fun things to play with instead of just worrying about verifiable credentials only kind of thing. And then into next year, the other two will be coming online as well, which is the Assurance Studio for the verifier side of things. I want to be able to basically create easy to use dashboard for creating an application that relies on verifiable credentials. So it allows people to basically, I would say, sign in using verifiable credentials, as well as have the data included in those credentials within the context of that application. And then later next year, I will be releasing the Verifiable Inc. suite of tools, which is the issuance side. So the same sort of idea, build a nice, or have a nice dashboard and stuff where you can kind of go in and set up your issuance flows and all that jazz. The Trinsic demo earlier this morning was a good demonstration of how that kind of works in the production environment. Cool. So I have a couple more slide decks. Maybe I'll check, is there any questions so far? Cool. If not, I will. I'll dig into the next bit. Oh, I heard a beep.
Looks like someone requested to ask a question. Hold on one second. So I just invited Phonics to speak.
Great.
Do you want to go ahead and accept that invitation to speak?
Can't find it. I don't actually know where it is.
If you're on, yeah, if you can see I think it's in the audience section of the app, if you're in the event. If not, you could also type in the chat. Yeah. Oh, okay. I think he's typing. Yeah. Oh, okay. He's wondering if the two products in the last slide could be used side by side in the same app.
Yeah, totally. So that's kind of the idea behind the Aviary One fashion or product. Sorry. So basically, it's a AV1 will be a single suite, so kind of does all three things. But then each of them is kind of broken up into their constituent parts, which will allow basically, kind of not overburden each role. So if I get people coming on that want to do verification only, would like build a quick little website or whatever, that'll be possible on Assurance Studio quite easily. But yeah, that's a good question. AV1 will do it all. Cool. Yeah, so I will dig into the next part here then. So this was the did method that I kind of alluded to earlier, and it's, like I said, very actively being developed. I think so. I have a call with one of the main Bitcoin ordinals devs tomorrow, and we're going to discuss I'm hoping to discuss mostly the update method and try to make it a bit more intuitive. So it's not right. It's not perfect as it is right now. So basically, this is not production ready. Is my disclaimer for that. But it's kind of fun. So basically, there's background on DIDs. I think I've talked about that quite a lot. And there's quite a lot of other people who have. So maybe I'll kind of gloss over that. And yeah, this is kind of the more important thing I would say for this talk. So basically, ordinal inscriptions, what they are is ordinal theory. Sorry, let me back up. Ordinal theory basically gives an identity, an identifier, a number to every Satoshi that was ever mined on Bitcoin. So it does this by doing like a first in, first out. So basically the first block or whatever gets the first, I don't know how many, but there's many Satoshis in there. And the Satoshi, by the way, is the smallest unit of account on Bitcoin. It's like a fraction of a BTC of a Bitcoin. So there's, I can't remember, but there's 100 million or something, maybe sats per BTC, something like that. 100,000 possibly. Anyways, so they found out a way to give an identity to every one of these. So you can use like an integer number. There's also a decimal format, which is kind of the block number dot the offset within the block. And then they also have kind of like a human readable name, not totally human readable. It's just like English letters. So it makes them possibly human readable. And then there's a couple other fashions, but they all, at the end of the day, identify the same sat. And so what you can do with that is an inscription, which is inscribing arbitrary data on top of that. So being able to do that opens up quite a lot of new avenues for, at the bottom there, you can see current uses that images. Basically, a lot of people have started to put images on there and calling them NFTs kind of thing, and allow people to buy and sell those. There's also, other naming systems, not DID based and in that fashion. It's basically just saying, for example, Brian.sats could be my sats name if I inscribe that first. People have also started to make like a fungible token protocol on top of that, which is a bit inefficient, but hey, people are doing it, so can't stop them. And basically, yeah, so these create unique Bitcoin native digital artifacts, which is an interesting idea. Being able to buy and sell a sat that has data associated with it opens up quite a lot of use cases. And they can be held in regular Bitcoin wallets, but if the Bitcoin wallet is not ordinals aware, it might kind of use those sats as fees. So if you're playing with this stuff, you do want to make sure your Bitcoin wallet is ordinals aware, so you don't kind of burn those inscriptions. You can transfer them using traditional Bitcoin transactions. There's nothing special about the Bitcoin transaction. Like I said, though, you want to make sure you're safe about it. And then because of all of these properties, they are as durable, immutable, secure, and decentralized as Bitcoin itself. So it's an interesting thing. It's only been a kind of around for the last, I'd say, 4 months. A guy named Casey Rodamore kind of coined the term and found out that you can kind of put arbitrary data in there. So those two things combined kind of created an explosion of interest in the space, because everyone wants to build on Bitcoin, it seems. So we'll go through the 4 operations that all the IDs have. So I've kind of outlined how they could work on Bitcoin ordinals. So basically, for creating, you can inscribe the full DID document. So on the right there, you can see the one that I did inscribe. I inscribed it on this SAT HOJ XRGLHUWZ. Not very recognizable, but it's quite a lot shorter than a lot of DIDs you'll see, because most DIDs are kind of a some sort of public key. So it is possible for you to find a SAT name that you really like, and you can kind of inscribe on that and memorize it, most likely. You can see in the rest of the DID document, it's a traditional document, DID document. It basically has one verification key, which is good for authentication and assertion. I do also have a short form of the ID, so to be able to save a bit of the transaction fees, I want to be able to basically inscribe less data because it does come quite costly. I'm not totally sure on that short form yet. That's my proposal there underneath the text there. That is basically a DID peer that kind of has a few little compression techniques. It's still not ideal. There's a couple other better approaches that I'm probably going to go with. But yeah, like I said, heavy development. So to resolve one of these DIDs, basically you can read the inscription off of the Satoshi. You look at the DID, you see that it's DID BTCO, some identifier for a SAT, and then you go and look up that SAT. Next, you kind of look up or check, like, has this SAT been spent since it was inscribed? And if it has not, then you know, great, this is the document for that SAT, for that DID, sorry. If it has been spent, you're looking at a receipt, because how this works is when the inscription moves, it kind of burns that state of the DID document and creates a new one or deactivates it, which I'll go into. Like I said, if you transfer a DID BTCO inscription, it essentially burns that DID document. So the DID document state is now kind of deactivated. However, if that that transfer also includes a new inscription, you are essentially updating the inscription. So when you send it off, you can look in that transaction and see another inscription, and that DID document, as it should be a DID document, will be the new state that your DID is at. I haven't totally figured out how to combine these. It is possible to do it in a single transaction, but like I said, this is under heavy development, and I'm hoping that this update state might entirely change into like more of a reinscribing the same SAT, which we'll see. So there are, of course, some advantages and disadvantages. The big advantages are like, this is layer 1 Bitcoin at its purest. The data is entirely on the Bitcoin blockchain. There's no second layer to look at. There's no other token to worry about. It's Bitcoin through and through, which is interesting because in my opinion, Bitcoin has like the greatest possibilities for network effects. As far as permissionless networks go, there isn't any that have as much notoriety or well-known name. Like everyone can figure out a way to buy Bitcoin. Basically, there's no hurdles in that manner. But then there is some disadvantages that come with that, of course. You do kind of have to wait for at least one block confirmation, I would say. Probably more if you're looking for a high assurance that the DID was inscribed properly. And it does become quite costly. At the bottom there, you can see a little while ago, I took that screenshot and it was $16 just to send a traditional transaction. And these ones are quite a lot more data than a traditional transaction. So it would be up there at that point. It's down a bit more reasonable level now, but as this gains more popularity, as Bitcoin gets more users, its design kind of makes fees rise, which is not really ideal. So there's a number of things for on the to-do list still. The biggest one that I mentioned before is I really got to deep dive into that update operation. I do want to change how it works a little bit, hopefully. But yeah, stay tuned. And then I want to build like a full implementation. Right now, I've just been using my hacky code, but I really want to get this into production as soon as possible because it's quite a powerful method, I believe. And then once I do have an implementation, I'm going to make sure there's a universal resolver driver, which Marcus, I think, will probably be talking about tomorrow in his session, which basically allows you to query one web server to resolve a number of different types of DIDs. So I would like BTCO to be one of those types. Cool. I think I heard oh yeah, 1 p.m. tomorrow is Marcus's talk. Cool.
Awesome. Thanks, Brian. Does anybody have any questions or thoughts?
Cool. Guess not. I do have a couple more slide decks to go through here. Show off another thing that I've been working on. Oh, actually, sorry. Before I do that, I wanted to show this. Basically, this is a full text search on Bitcoin, and you can search for did BTCO, and you can see that the one I have inscribed is still the only one on the blockchain. So it's an interesting that you can kind of query this one location and you can find it on all of these different explorers. You can go read the blockchain in quite a few different services. So yeah, there's my did. Yeah, so the next thing I want to talk about is verifiable collectibles on the Bitcoin blockchain. So this is using the same technique I just discussed called ordinals. And you'll often hear people talk about verifiable credentials in the sense that they are verifiable claims about a person or a natural person or thing like that. So that means those claims, you want to keep them private. You want them to be off chain. You want them to be sent directly to the holder. But I have been inscribing some of these verifiable collectibles on Bitcoin. I don't find it to be a privacy risk, as I'm inscribing just data about a piece of art, for example. So my brother's an artist, and we've kind of gone through and created some of these credentials and then inscribe them onto Bitcoin, which allows people to buy and sell them. So it's an interesting way, a flip on kind of on the data model. Verifiable credentials data model is quite powerful. It has a lot of very interesting properties, and I don't see there being like any limiting factor. I find that like I think everything is going to be a VC. Like all data is going to be verifiable sooner or later. So yeah, I'm playing with this in this fashion, and it's been interesting. So yeah, basically, like I said, they're on-chain verifiable credentials. So they are essentially a digital collectible that the subject of the credential is about that collectible. It's about that SAT specifically. I've been using static keys, did key, which I mentioned earlier. This makes it basically so I can't go and delete my did or whatever. Like some of the did methods kind of open up the opportunity for you to make your VCs unverifiable. Did web is a good example of this. Basically, there's no history in did web. It's just the current state from the web server that you're querying. So you can just turn that web server off, and then you have no way of finding that public key. So I want to make sure that they are always verifiable. So that's why I'm using did key in this example. And like I said before, that's the subject of the credential is the SAT number. So it's included inside the VC as the credential subject ID. Yeah, another thing I wanted to show here is you can kind of go here and see that this collectible is renderable. We've embedded a bunch of metadata in here, and as well as the image, as you see. You can kind of go to a few different places and kind of render these. So you can go to the main Ordinals website and see them. It doesn't look great there, but you can see all of this JSON data is on train. So this is the same thing I was talking about before. I'll skip through that. This is a bit of a rundown of what is included in those verifiable credentials. So basically, it's a JSON LD document. In the context, it uses a bit of a hack called @vocab, which you can see on the right there, and it allows me to kind of put arbitrary claims in there. I don't have to conform to a JSON LD context. And as I'm in active development here, I kind of don't want to be painted into a corner. And the contents of the credential is the image, of course. The metadata about the credentials, such as like the issuance date, the issuer, those sorts of things. And then, yeah, well, the provenance is the issuer, which is important. It's interesting doing this because the other people that are selling these inscriptions on the market are selling just images. They're just selling basically a JPEG. There's no verifiable nature to them. There's no provenance in them, so you have no idea who made that inscription. The only way you can verify that is basically someone says, "I inscribed number 1,200 or whatever." There's no there's no way to verify that other than kind of the looking at who made that, or sorry, which public key or private key, I guess, made that inscription, which Bitcoin address. But that isn't the best approach, in my opinion, because there's a lot of, it's mostly all inscription services that people are using. So you go onto some web app and you kind of upload your image and they inscribe it for you and you pay them. So at that point, it looks like the provenance is that service. So using verifiable credentials, you have that actual issuance provenance of the credential. And of course, that gives us the verifiable nature of it. So you can always verify that this image was issued by that issuer, and you can make sure that it wasn't tampered with or anything like that. It also contains the SAT number. Like I said, you can see in the credential subject, it has just the blank Satoshi number 94272. This, I've created these before I'd coined did BTCO, but ideally it would kind of be the same sort of fashion. It would be did BTCO 9427 or whatever, and you would know that that's talking about that Satoshi. And then I'm, also trying to work it into a collection standard kind of thing, where right here you can see identifier, but yeah, that same sort of thing. I want to make that into more of a did BTCO type of identifier. Yeah, so basically, I think I went through this sort of before. The required properties for a DID in this kind of ecosystem would be that the key is resolvable forever. And I definitely don't want to be using DIDs from a different blockchain or top layer or whatever being tied into something that's not layer 1 Bitcoin. If everything is within the same network, it makes it, a million times better. The interesting thing is you can kind of use any crypto suite that you want on your verifiable credentials, as long as it has been, everyone knows about it and they are able to verify it. So for this, I used ED25519. And then when I did that, a lot of people in the Bitcoin world were like, well, why didn't you use Bitcoin crypto? But I was like, well, you can kind of use anything. So that's kind of the point. And like I said, it is possible to use Bitcoin as well, which I will be doing in the future. Then there also is the possibility of using BBS Plus. for selective disclosure. So basically, that could work by you would inscribe a proof of the document of the credential, but you wouldn't inscribe all of the claims. So you would be able to send the actual document, the actual claims, the VC to a holder, and they would be able to prove some of the claims, basically create a presentation that includes some of the claims of that credential, and the person they're presenting to would be able to look at Bitcoin or find it from Bitcoin to find you even. So that gives quite a lot of interesting opportunities, kind of like maybe being able to selectively, slowly reveal some of the attributes about a collectible, or having collectibles that are more private than having them all kind of public on the ledger. So why do this on chain is obviously an interesting question. The number one thing is like being able to buy and sell these verifiable data objects. Basically, I did it one day, and instantly it was available on like 3 or 4 marketplaces. I could sell that item. There's, it's like I said, it's only about 4 months old, ordinals, but there's already at least, I don't know, 6 marketplaces that you can do this on. So it's quite interesting. And another cool thing is like you're creating public immutable information that's going to kind of live on Bitcoin forever. So on the right there, you can kind of see we made this collectible related to some endangered animals. Those the collection series. This one was the American bumblebee. It has all this information about the bumblebee, and it's going to kind of live there forever, even after this bumblebee is sadly extinct. Another interesting aspect of this is that you don't actually need a backup server, because you have your keys. You can kind of just query the blockchain to pull down all of your collectibles. So it allows for like a trustless fashion in that, where you don't actually need to remember all of your collectibles or where they are, or how to get them. You can kind of just look at your Bitcoin wallet and pull that information in. So some of the possibilities this kind of opens up is being able to do a ticketing using verifiable credentials, and you would be able to basically have instantly secondary markets that you could sell these tickets on. So if I go and create 50 tickets for some online event or whatever, DidHack, for example, you could basically sell those or give those away, and then those participants would be able to kind of buy and sell them on the secondary market. Also, you could do coupons, in-game items. A lot of these use cases are possible with straight verifiable credentials. Don't get me wrong, but the secondary markets and the public information, like I said before, is valuable traits for sure. So there's a bit of work still left to do, of course. This is kind of just a fun thing I've been playing with. I am partway through writing a specification for it to get all of the technicals kind of down. And I know I also need to basically create a way for a holder of one of these collectibles to create a proof showing that they own it, and making it like verifiable using the same sort of data integrity suites that verifiable credentials use. That's the same sort of question, or the Bitcoin ECDSA signatures on the issuance is another way, fashion to do the proof in the first place on the collectible. And also I want to make some utility websites to kind of show how powerful these on-chain credentials are. Basically allow people to log into a website or receive a Discord role or a new airdrop kind of based on an attribute that their collectible has. That one actually I did do. We have one series called Ninja City here, and we had some of the ninjas had a hidden weapon attribute, So all of those hidden weapon ninjas, we gave them a free weapon. Yeah, and I think that's it for that. I think I heard maybe a noise. No, cool. Yeah, is there any questions about verifiable collectibles? Yeah, the one thing I wanted to make sure that I stressed, and I don't know if I did enough, is like, if you are to do this stuff, do not put private data on the Bitcoin blockchain. It's just a bad idea. I can't stress that enough, basically. Cool. Yeah, so it looks like I have a bit more time here, so I will kind of dig into the documentation I do have about my the Aviary Tech ecosystem. I kind of got a bit of the core concepts in here. I just kind of made this last night for people to play with. Basically, I've outlined some of the core concepts here. Decentralized identifiers, of course. Very brief and to the point. It talks about the technical details as well as the kind of an introduction to them. Some of the DID methods that I build on and use. I document them a little bit here, kind of make sure that I discuss the advantages and disadvantages of each. So this is kind of a reiteration of what I presented in other slide deck. They all have their advantages and disadvantages, that's for sure. There's also a bit of a deep dive into, or shallow dive into verifiable credentials themselves. And then also DIDCOM, which you might not have heard much of at this at DidHack so far, but it's a powerful technique of DID-to-DID communication encrypted. So I do have all of my libraries that I've discussed are open source. Unfortunately, they're not yet well documented because they're in heavy development, but they do have, they are well structured and they're all structured the same way. So it's not too difficult to navigate them if you want to dig in and learn a little bit about how these technologies work. So mostly, this is the crypto suite tooling. So there's a bunch of the suites that I talked about before. BBS Plus, ED25519s, X25519s. This is the Bitcoin one that I'm just working on, JSON WebKey. Yeah, a few of those things. The same sort of goes for the verifiable credentials library. In the lib, you can see the services. There's the issue, present, and verify. Yep, code's all in there. And then, of course, the DIDs as well. Source, lib. There's DID resolver, which basically is a plug and play tool for you to kind of plug in your different DID methods. I have DID web and DID peer plugged in here so far. What else is there in there? There's basically an interface for DID document, which is quite handy. Secret resolver allows you to kind of have different ways to save your secrets. So like you can have it in a JSON file, environment variable. I think this is the base class kind of thing. And then finally the DIDCOM library as well. So this one's interesting. It does use the SIGPA DIDCOM envelope library, which is a Rust library that has a WASM binding. And basically this is kind of a wrapper around it, which has like queues basically for handling receiving messages and handling sending messages. So basically, you can kind of add some callbacks, like if I send a basic message, then throw this callback as well, which will log that message or something like that. You can kind of dig into all of the different messages within a protocol. So it's split up in that fashion. There's kind of a file for every message in a protocol. And yeah, I think that's kind of it for my libraries. And that's it for the documentation. Cool. Yeah, so if there's any questions, please feel free to shout them out if you can request or type in the chat.
Yeah, I don't see any questions coming through. There's also Aviary Tech channel. So if people want to also ask questions async, there's you'll find that also in the breakout sessions section of Discord.
Yeah, and I'll be around to answer questions as soon as possible. Basically, I've been already getting a couple there and talking to the guy. So
Awesome. Thanks, Brian, for presenting. And also, I want to remind people that we're going to break until 1 p.m. And then there will be a session from doc.io from co-founder Alina Kadori and also their head of engineering, Mike Parkill. So definitely join us back here at 1 o'clock. And then tomorrow we have TBD, Angie Jones, VP of Developer Relations at 11 a.m. Here at the same location. We'll be talking about how the TBD ecosystem works. Also, we'll be including a discussion on decentralized web nodes. And then in the afternoon, we have Marcus on DID resolution at 1 p.m. Pacific time. So I hope to see you guys very soon.
cool. Good luck, everyone. Hope you build something great.
All right. See everyone. Thanks for coming. Bye.